include predictive maintenance, supply chain management, and artificial intelligence in manufacturing systems. Dr. Soni has guided several doctors' theses in his areas such as integrated production and distribution planning, inventory optimization, and risk management in new product development process. Sir will be presenting today on Introduction to Smart Manufacturing and Industry 4.2. We are truly fortunate to have him with us today, and I invite him and all to extend a very warm welcome to Dr. Gunjan Soni. Over to you, sir.
I'll stick to the theme of the short-term program. Smart manufacturing is what topic has been given to me, and I'm really very privileged to share my thoughts on this. I'm basically picking up a case of 3D printing hubs where it exhibits state-of-art use of technology, which bridges the gap between, the spatially distant organizations, how they can work. And this presentation is largely an amalgamation of technologies such as, of course, 3D, as you see, is 3D printing is there, AI and IoT. All these three technologies are integrated in this case. So basically, if you see at the introductory title, it says 3D printing hubs. So I'm sure some of you might be having an idea about what is 3D printing hubs, but let me just see if we can sync on that again. So of course, we know that what are the advantages of additive manufacturing and why, what applications does it have in what various sectors, that we already have an idea about that. What are the economic advantages? I'm assuming that our audience is already well versed with all these basics of 3D printing. So I'm not going to focus on what are the advantages, of course, right? A small video might be good enough to brief about what is additive manufacturing. So I've kept the link over here for the people who would be joining, who might have not have joined earlier. They can watch this. But what I'm coming to the point is a 3D printing hub. So the 3D printing hub is a third party where which acts as an intermediary between the consumer and the producer. So who's the producer? A producer is the organization or a company or an individual having a 3D printer, while consumer could be a business to business consumer, or it could be a business to consumer transaction. So I'll show you two websites, Shapeways and Ponoko. These basically are the people who are acting as a 3D printing hubs. So let me just take you there. I'm sharing the screen again because the window is changed. So you see here, Shapeways is a digital manufacturing service, and what you see over here is, so they are using various type of technologies over here of additive manufacturing like SLS, MJF, SLA, SLM, and various type of materials which they are offering. And several industries are taking their help. For example, if you take medical, so these are medical applications where they are probably printing prosthetics, pre-surgery visualization models, and medical devices. They're using additive manufacturing in that. Now, this is the basic framework of their working, where you upload your SLS file. They can also help you in making SLS file. Upload your file over here. Then you select the material from the top. You can select that what type of material do you want for your manufactured product, and further they'll print the item using their own industrial 3D printers, and they will ship the product to you. So basically, this is a 3D printing hub. The idea behind the 3D printing hub. There's another, and of course, the industries that they are catering are several. So you can see the variety right from jewelry to medical. They're all they're serving for all these industries. Beyond this, if you look at it, there's another one, another organization, Onoko. They are also providing the similar service. So get custom parts delivered in hours, where basically online quote in seconds, and they collaborate with the sales. So you can collaborate. So they are also providing the expertise of collaborating with the sales engineer, where the support is there, and upload or drop CAD files here, and then various type of files which it can handle is over here. And then you can take a quote of your design. And again, similar, you'll find it over here. Various types of services, manufacturing services are being offered over here. So this is what we are talking about in today's lecture. How do these companies work on, what is the model of working, and how do they work on it? And so basically 3D printing hubs, they provide a platform where distributed 3D printer owners can post their machine information, and customers can easily access these services, and distributed additive manufacturing. Now, main advantage that you see over here is uh, it it is diminishing the spatial distances which are there between the consumer and the producer. If I'm sitting in a very isolated island and I need a product for which I have lesser awareness also about how to make the design, also I don't have a designer, so they can help us in making this. So this is a service with a product. Okay, so we can go ahead now. I think the slides are visible or not. Can you confirm me if the slide is visible, because I've changed the windows.
No, sir, slide is not visible.
Okay, I'm sharing again. So this is often going to happen. I'll be shifting between the slides and videos.
Now, sir, it is visible.
Okay, so I'm not maximizing it. I hope it is okay, because I'll be shifting between the various hyperlinks and the videos subsequently. So if you look at this framework now, we come to the framework. This is current workflow of the cloud 3D printing. So another technology which is very imperative in this framework is the cloud service. So now you see over here, there's a user, and the user will upload the CAD file in the cloud. That's what it was. The link was there on the website, which you have seen. And then there is an operator at the 3D printing hub, is your service provider. He's going to operate that machine, and the part will be printed. So what you see over here, there are several issues which emerge because of this framework. One is the communication between the machines and the cloud. So what you see over here is a user, and he's uploading a type of a file, and the machine is expecting that kind of a file. Now, in between whatever communication is happening, that communication is an issue, because cybersecurity, of course, your design is proprietary. If you are a business owner, you would not like your design to be out there. So security issues are there. There are issues of protocols of the communication, and oversimplified service definition. Now, if user does not have a technical know-how or does not have a technical skill to assess the design, then there is a problem over here, because user may not know what kind of material he wants, user may not know is the design feasible or not. So this is an oversimplified service definition where user may provide the input, but the input is vague. So let's see one video where it exhibits the limited support for design of additive manufacturing. So why we are saying it is smart? Because what you see over here is just uh, I'm losing the cursor over here. Actually, I have to select this link, but cursor. Uh, just a second. Now it will be fine. Yeah. So the vagueness of the design being provided by an inexperienced user will create a problem. So let's see uh, a video, small video. I'm sharing the screen. Why I'm showing this video is that uh, there is an expertise required in between. Okay, this expertise has to match the consumer requirements. So the kind of challenges which are there in front are there in this video. So you see here this kind of expertise which is exhibited in this video. This is what is required by the service provider. So I'm sharing the slides again. Now we come back to this. So there is limited support for design for additive manufacturing. That kind of expertise which was there in that video, this is limited in general aspect also. So what if there is an integration of a knowledge-based system in between, where it is integrated with the cloud, and when the user inputs its design, the design is churned through an expert system which is based on the knowledge which is there being carried out. Because what 3D printing hub is having is the lot of information, a lot of knowledge which will be created over a period of time when the number of orders increase. Okay, so so what is the architecture of this? How does this additive manufacturing process through 3D printing cloud works, and where is that expertise coming in between? Uh, the the service provider is not simply a contractor, rather is also acting as an engineer and a counselor in between, where the designs are probably getting modified. Okay, so a cloud-based additive manufacturing platform, CAMP, is an environment created which links outsourcing demands of additive manufacturing to the distributed additive manufacturing services. Now, I can also enroll my 3D printer if let's say I'm having a 3D printer. So I can contact this cloud service provider, that I'm enrolling my printer for printing with your organization. So all the rich data and expertise which is already stored in the cloud, my system will get connected with that cloud, and all the technical know-how, I can also tap that and make the product. So this is what 3D printing intermediary is doing. So service providers can connect their printers and other printing resources to the cloud and upload resource capabilities and know-how. So it's just like Uber, no? So if I'm having a taxi, I can enroll my taxi in the Uber, and customer can use my taxi, and I will put my specifications out there, like who will be the driver, and similarly what kind of capabilities of my 3D printing machine, whether I can do FDM or I can do SLA or SLS, whatever capability my machine is having, I'm going to upload that. So it is enabled by IoT that way, because IoT is what enabling is creating a link between the physical machine and the digital twin which is present at the cloud provider. So it is enabled by IoT, where various printers are able to directly connect to the cloud. So remote control and monitoring of the product being manufactured can be achieved. So in this environment, printing service is defined at a lower level. Uh, as while its control and the monitoring capabilities are there with the service provider. Uh, so we can go ahead. So now if you look at it, service requester is a person like me and you or a business owner, and the platform provider is taking the description of the machine which is there, and it is delivering what kind of services it is delivering. It is delivering expert services where service provider has the 3D printer, maybe maybe a digital twin of that, because the machine might be located somewhere else around the globe. Then the material, then the sensor and software data and know-how. So actually, what you see over here is an excessive migration from the limitations of the physical entity is there in this model. Generally, an engineer would carry the know-how and the data and how to carry out, how to modify the design. But over a period of time, when these services are availed by large number of customers, this database is going to grow stronger, and the knowledge which is being created by providing service will get richer and richer. So the more the number of customers this system will cater to, the more expert the system will get in perfecting the design of the 3D printed product. So this is the basically additive manufacturing information flow. Uh, so you can say process planning and designing. Uh, they can be divided over here. So the requirements are going to the process planning module as well as the design module. In the process planning module, the processes, what type of process is suitable for what application. So these all requirements will be taken from the consumer, that what is the application of this, and then the process planning is done and the printing parameters are set. And from the design point of view, the CAD model and an STL file will go where and then the G code will be created based on the process planning and the design or the STL file. Uh, and then the sliced contour data will be created based on that on, and then hence you get your G code, and then the printing will take place. We will go deeper into this architecture. So this is the platform structure where there is a physical resource layer, there is a virtual resource layer, and there is a service layer and an application layer. So you can see basically four different types of layers are given over here. Now you see here the four layers: application layer, services layer, virtual resources layer, and the physical resources layer. I have also included several videos on what are digital twin and all. So let's see one video. I think it would be refreshing for you to have a look at one video on digital twin. I'm expecting most of you would be having idea about it, but I'm just taking a chance. So small video. So again, sharing the YouTube screen. So what is a digital twin? Let's see. Video speed I can. Digital twin, what's happening over here in this particular case is that digital twin of the 3D printer is created at the cloud service provider. Now have a look at this architecture. So looking at the physical resources first, there are soft resources and there are hard resources. So basically 3D printer is located over here. And then the materials and the computers. So these are all your hard resources. Then soft resources, these are very important. Design rules, test data, software, and uh, the technical know-how all goes over here as the soft resources. Here initially human resources can be employed for creating uh, the design rules or creating the know-how, and then subsequently and all that uh, in structured form using the type of data structures which are required, they can be stored over here in knowledge base and database. So this is the software toolkit which goes as an input to the virtual resources. So these soft resources gets converted to the virtual resources, and these hard resources, uh, like for 3D printer, interface will be created where a user interface where a 3D printing machine in its most representable form would be there as a cyber twin, and all the controls which are there will be evident in that digital twin, and all these are integrated with the IoT. Like if I press the button on my screen, the button of the 3D printer should get pressed, the physical machine. So that connection would happen through IoT. So all the protocols which are required to establish an IoT interface between the digital twin and the real resources or the physical resources needs to be created over here, and hence you create the virtual resources. So if you look at it, the virtual resources are the cyber twins, the digital twin, you can say a CAD model with the buttons on it and various dials which will indicate the process parameters will be there on the screen, and at the back end will be these virtual resources like software toolkit which will help in making that product. Then you have the services, which are knowledge management module, process planning module, design assistant module, slicer toolpath generator, monitoring and self-diagnosis module, and the security management. Now let's have a look at them one by one. So in the knowledge management module, you would be having model construction, interface, and evolving. So what's happening here, evolving is, let me tell you that let's say for customer number one comes. Now there is nothing in the data knowledge base. There is nothing in the database right now. So customer number one will give the design. The design CAD STL file would be captured in the database. Then the engineer will look at the design and will look at the application and will comment on that design, will annotate the design, will look at the suitability of the manufacturing of the design. All these observations will be recorded now. Here you can see large language models are very useful. It was not there when this paper was when this case was presented, because after 2022 only we see the realization of the large language models. So this software toolkit is getting even more uh, enriched with the use of large language model technology. So all these observations, they might be in uh, natural language. So that all will be stored here in the knowledge base. Then of course, the engineer will initially the human intervention is required. But let's say after 500 or 600 designs, this knowledge base is getting richer and richer. Now, hence you see the word evolving is coming, where knowledge management module is now getting more and more intelligent with the increasing in the number of designs which are coming in from the customers. Artificially also it could be done by introducing more and more designs by hiring, let's say you hire a engineer for an year, or you hire an engineer and whole day what this engineer has to do is to pick any random design from across the possible available resources and the applications and has to comment on that design. So hence your knowledge base is getting richer and richer and is evolving. So it's like your own virtual engineer is getting developed. Subsequently, the additive manufacturing expert also is required along with the engineer initially, where he would be commenting on the process selection, parameter selection, like whether it should be a material extrusion process or polymerization process or powder based fusion or material jetting for that particular one. So all these process planning modules aspects will be covered in that. Again, this is also being added to the knowledge base. So hence your process planning module is also evolving, it's getting prepared. Design assistant module, where structural optimization printability check will be done. So these are all part of the services which are being provided by the cloud manufacturer. Subsequent, and then you see the slicer and the toolpath. So this all output initially was being done by the human beings. These all services are being delivered by the human beings who have the know-how in that. Now, it's not like that we will never require human beings once the knowledge base is there. There's always a requirement, there's always a variation, there's always a innovation, there's always a change in the design, in the requirement. So this knowledge base needs to update itself, and this updating could not be left alone on the machine. There has to be a human being who's intervening in between at times or randomly checking the design being proposed by the knowledge base, the expert, their digital expert, and then monitoring and self-diagnosis, security management. All these modules will actually run on the knowledge base. And subsequently, there will be another. The communication interface has to be there between the service provider and the consumer. So that is the application part where we see the website, we see mobile application. So these are front end services which are delivered by the applications which are there. So we go ahead. So product development process in this is quite simple. You see, so now look at this service requester, platform provider, and there is a service provider. The service requester is the consumer like me and you. So the service is like a product development service. Now in the product development service, if you look at it, there's a process planning module and the design module. And then here is your platform provider. So platform provider is like in the previous slide we have seen, it will retrieve the information. So in the product development process, your process planning, design, and the subsequently printing of it is taking place. And here's your learning engine. So basic, you see here that database and knowledge base, and all these soft resources are going in the learning engine. You create a knowledge model. So learning engine basically could be a machine learning based model where a lot of data is there being churned and inferences could be coming out of it. So hence you create an inference engine, which is basically a decision making tool working on the knowledge model which has been created. And you see here, it is getting the queries are coming over here in the inference engine because uh, it's sort of a decision, it's sort of an intelligent engineer which is sitting over here, which is answering to the queries raised by the design team, raised by the process planning team in the sense virtual. So these are all the connections which are to be established between the various modules, like process planning module. If you create the design, when the design goes in, the process planning module will create the basic requirements, preferences, and the desired range, and select the printing strategy. So initially here in the process planning module, initial filter is about the basic requirement. When you lay down the requirements, they'll be filtered through various ways, whatever is available and whatever has been created. And then option navigation. Now you have several designs, several possible modifications available. So it takes input as a preference and the desired range of the consumer. And then various options are ranked. And then the right printing strategy selected. So this is your process planning part. Subsequently, once your process planning is done, then the design library. This design library is created over a period of time in the cloud by the cloud provider. It is not there initially when you start it. It could be there if you take some third-party data and do that. But if it is not there, you may have to uh, create your own design library, and then keywords, initial design, and design constraints, and the final design all needs to go as an input to the design library. And then there are design rules, which are sort of a constraints, which are also coming from the inference engine because it is storing all the database. And these design rules are going in a design constraints, and then the design optimization is happening. So the initial STL file which is given by consumer may not be printed as it is. It is going to this the inference engine, whatever the output is given by the inference engine, and then the final design which comes out of it, sort of a churning which is happening, it's sort of a mixer where the initial design of the consumer gets modified according and it's not necessary that it will be modified. If it's already perfect, there may not be any requirement of modification. But this is the basic service which is being provided. This is the intellect which has been provided, not simply taking the design, printing it, and sending. Okay, so this is the service which is being provided, and subsequently it goes to the manufacturing where the slicer tool and the path generator module is there. And here is the use of the digital twin where the task is sent by the digital twin to the physical machine, and real-time data exchange is there between the digital twin and the hard resources. The printed part then goes, and the monitoring and the cell diagnosis of the machinery is taking place over here. Printed part goes for the shipping of the product. So this is the whole architecture. Now we go ahead and because of the limitation of time, I'm skipping some part. Or I'll be giving just a brief of. So this is you can say a Bayesian network which is being applied on the design optimization, where how can you change the design so that your product is made. So this is being applied over here, where Bayesian network model is applied for designing the features and their qualities in the FDM process. So so cyber twin is being developed over here for each printer, and there's a communication protocol which is being established. So it will be important over here for me to tell you that while it's easy to say that there is a computer and another machine needs to work on with the control of this computer, but how does this computer and that machine communicate with each other? So for that you have OPC UA protocol. I mean, there are multiple protocols available, standard protocols for open source So OPC UA is one of the most common protocols. We can see that. So I'll just run this video, or maybe you can see it later. It's not necessary that we see it right now because only few minutes are left. I mean, another 15 minutes are left. So I'll share the slides so you can see that later. So OPC-UA and MT Connect are the two protocols. I mean, more popular protocols which are used in IoT technologies. So this is your server, which is there at the cloud provider, and then there is the client and the data source. So this is all information which is happening over here. So the information model, that how this because now you see that there needs to be a structured way of representing the information. So the structure of the information is playing a central role. If the data is not structured, how will you create the knowledge base and how will the design get modified? So it's just not possible without that. So hence we create a communication process is established where nodes have different attributes to describe them, and it can belong to different node classes. So very crucial, there are three crucial node classes over here, which is object, variable, and method. So a node belonging to the node class object will consist of variables and the methods. So for every type of method, there will be several variables which are governing that. For example, FDM. So there are several variables defined for running an FDM machine. Okay, so that's what it means over here. A node belonging to node class variable represents a value. So the deposition rate and the temperature, these are all the variables. And the method that can be called by client and return results. So basically, if you say I'm selecting fused filament fabrication. So what are the so this is the method, and what are the variables associated with this? So you can see over here that this is the information classification model, or how your database will be created, where object and variable and method are represented by rectangles and smooth edge rectangle and ovals. So first use type of the 3D printer is the object type. Similarly, in the description is equipment ID, technology type. So that's again a variable, and the name and the material is a material type, and feedstock, what is its type. Further classification is there. So you, while creating such technology, this kind of information structure has to be created. Once you create that structure, then there is another aspect of this, which is self-diagnosis. A 3D printing task is given, but at times the machine may get heated up and may stop working for a while. There could be a deposition of material at the nozzle for and the nozzle gets blocked. So uh, these kind of failures or these kind of obstacles which are coming may not be very good for the process, and you would want to detect it pretty early in the whole process. And self-diagnosis is something which is uh, so self-diagnosis is sort of a predictive maintenance which is there with the process. So you can see here, it's pretty simple. We can go ahead. So problem classification could be there, where uh, errors which are problem classification from the point of view of diagnosis. So there could be 5 classes of problems in the 3D print while you are doing 3D printing. Could be detachment, missing material flow, deformed object, surface error, deviation from the method. So all these are various type of errors which could be there in the material extrusion process. So in general, the problems that are identifiable from the visual images can be divided into. Now, we are specifically focusing over here on the visual part, where a geometric failure or a surface defect is there. So, how diagnosis could be there and how AI can be used over here. So, augmented reality is used over here. Augmented reality, what it's doing is there will be a camera on the machine, and with the help of augmented reality, you would be able to constantly monitor the part being made. And as soon as a geometric failure or surface defect is detected, it will be communicated to the user or maybe communicated to the operator, where a operator may not have to have his eyes constantly on the machine. So the authors have used over here artificial neural network. So what they are done is that several images. So this is just the basic architecture which is represented over here of the ANN. So you see here several images, two images are there, whereas these are the training images we use to train the artificial neural network, where acceptable surfaces, multiple images are taken in RGB, uh, because it's going to take less memory, and the real-time decision making would be faster. So hence, of course, colors don't matter over here. So this is a very nice part which is being printed. So this annotation needs to be done of the images. Let's say 2000 images, 3000 images are taken from various angles, and the defective ones are annotated, and the non-defective ones or the okay ones are annotated that this image is fine, acceptable, unacceptable surface. And this camera is always there on the printer while on the object where while it is being printed. So I'll show you the physical setup also. So RGB images are used, and the pixel size has to be decided, because the larger, the sharper the image you have to see that what quality of image is required over here. If you take a very high resolution image, your algorithm would be running slow, and the real-time detection would be slower. So again, this is an optimization aspect over here. They use 3000 images to train the model, and then these are the results of the neural network training. So eventually they did that, and after I'm again telling that why you talking about neural network over here is that we are trying to detect there is an impending problem in the system, so it could be detected in the real time. So a prototype system is developed to illustrate the functionalities of the proposed cloud platform framework, and a printer is set up, and a load sensor is used in this, where camera is used to capture the part printing process information, and load sensor is to track the remaining weight of the filament, because while the material is getting deposited, the weight is going to get lesser and lesser. And information model that we talked about earlier is developed in XML, and OPC UA protocol is used for IoT platform, and Raspberry Pi is used using free OPC UA library. So you see over here uh, this setup which you see over here. Inside there is this 3D printer, and this is your Raspberry Pi for IoT. And here is the load sensor for checking the weight of the filament. And inside is the part. Inside the structure is the 3D printer, where this camera is constantly monitoring the printing of that. And this camera is sending the images to the neural network for checking the defect. If there is an indication of the defect to the neural network, the process might get paused for a while, and there will be a worker operating the machine to have a look at the problem and further go ahead. And on the right side, you see is the information model which has been created in XML. So current functionalities are distributed in different product development processes. Over here, you see uh, there is a resource list. Basically, the type of you see here, ID of the machine is given, name of the machine is given, type of the technology the machine is using, the material which is loaded on that particular machine is given, and the status of the machine, whether it's working right now or engaged. Then further is ranking of the various designs, possible designs. Once the STL file has been uploaded, this is the feature library. Optimization of the design is happening over here with the design rules. There is a simulation also that happens where if with these design rules a part is printed, how would it look like? What is they'll run a FEM model of that and check the strength of the model in the simulation. And this is the web interface for the operator, and the part status could be actually seen in real time by the consumer. So this is the functionalities in the product development process. So basically, if you like to conclude it in a way that how ICT is actually transforming the whole idea of smart manufacturing, how AI is coming into play, and how cyber physical systems are evolving in this environment. So I hope you would have enjoyed the presentation. Uh, if now you'd like to open the forum for discussion. So if you'd like to have any talk over here. We have 5 minutes.
If anyone has queries, please write it in the chat box. Sir, I suppose there are no queries for now. Sir, we
Okay.
have a query.